Hey guys, welcome back everyone. So let's get started. I hope everyone is doing great right now. Yep. So what we have done, we just finished the 1 week, right? And I know in a 1 week we have missed the one classes, right? Because of my emergency. That's not a big deal. And we have also covered lots of things, right? We have seen all the basic fundamentals of the networking, like whatever the devices we have in the networking, like a router, switch, hub, right, PC, and host like a servers, printer, right, and the WLCs, right, AP. Then we have seen that also like whatever the types of traffic we have, like a unicast, broadcast, and multicast. Normally, unicast one-to-one broadcast means everyone, right, and multicast is a very good example of the WhatsApp group. The main purpose of the networking is what? It's used to exchange the data. Data could be anything, right? It could be the information, video, MP3 file, watching the movie on the YouTube, on the Netflix. Everything is data. So my is noting everyone right now. So everything is data. Then after that, we have seen that every person has a address. For example, I'm living in the one location in the Bangalore. So I have also address. So if I'm gonna order something from the Amazon, so they will deliver to that address. Same thing on the internet. Internet is a totally new world. It's not a human world, it's a device world. Okay, in that world, what happened? Every device needs some identity, right? At the same time, location, and that comes in the picture of IP. IP is going to provide you the location and identity at the same time. IP is a 32-bit address, IPv4 addresses as well. It's in the dotted decimal format. We have a different classes of IP addresses, right? Class A, Class B, and Class C. That is totally unicast and broadcast. And then we have a Class D and Class E for the multicast and documentation purpose. We have a subnet mask for the each classes. That's gonna tell you how many network person and how many host person they have. So if you have a big network, you can go with the class A. If you have a small cap, go with the class B. And if you have a very small cap, go with the class C. Then after that, we have also seen that what is the collision domain, right? And also we have covered like how the things are working between the hub and switches as well as. So there is a difference is that, so take example, this is the PC, right? And this is the hub we have. And this is the another PCs, right? And this is the another PCs we have and another PCs. Take example, we have PC number 1, PC number 4, PC number 2, and PC number 3. So if this PC, right, have a, source address is PC1 and destination is PC2, you can see that this is a pure unicast packet. In this case, what happened? The packet comes to the hub. What hub will we do? Hub will retransmit this signal to the every port. The packet is still unicast, but hub is doing the broadcasting. That's the biggest issue with the hub. And that's why we call as a hub is what? It's a dumb device. They have no idea of the unicasting, broadcasting, and multicasting because it's a layer 1 device, right? He does not understand the any types of packet. And that's why we avoid this problem. We came with the concept is called as a bridge. But again, bridge, right? It was used for the smaller network, but not for the big network. Just for the technical perspective, if I tell you, the bridge only provide the connectivity of between the two collision domain. Not collision domain. It only has a two collision domain. That's all. So it means that you can provide the two LAN network. That's all. If you have a take example 50 plus LAN network, you cannot do with the bridge. And that's why, right? This is the reason behind it. We came with the concept is called a switch. And switch has a beauty is what? So if the PC1 wants to send any data to the PC2, take example, in that case, what happened? If packet comes to the switch 1, what switch will do that? It will just transmit the packet to the PC2. Same, the reply comes in the switch will transmit this guy to the PC number 1. So pure unicast to unicast communication is going on. So switch has the ability, it can understand the unicast packet, right? Can understand the broadcast packet, can understand the multicast packet. All good, right? So that's we have covered till this point. Okay, now let's go into further. That's we have seen the, okay, we have also seen the private and public IP address concept, right? So, and it's one of the organization, right? So this is the one of the organization companies, right? Where the people are sitting over there, right? And they are working to provide the number system. So they provide the IP addresses and ASN number 2. Private IP address could be the two types. Either you can go with the private and public. Private IP address right now, it's a free to use, can be duplicate, and it's not routable. Not routable in the sense of what? If the user, take example, if this user has IP address is 10.1.1.1.1, right, /8, that's a class A IP address, this guy directly cannot reach the internet. You cannot send the traffic directly to the internet. We need something, right? Either we need to, put the public IP address, right, 1.1.1.1, or either we need a guy who will translate, right? I need a guy who will translate my private IP into the public IP. That's called as a NAT. That we'll see in the next, advanced lecture when we're gonna do the routing part. Then we'll see that. This one. Then we need a NAT. But directly, right, if I talk about directly, this guy, they don't have ability. They cannot. That's something, it's not routable. You cannot reach it. And the good thing about the public IP address, it's routable. So if you define the public IP address, for example, this PC, right? This is the PC that has IP address is 1.1.1.1/8. This is the public IP, right? See, this is the range of what? Private. So if I'm going to define the public IP of this guy, he can reach to the internet directly. In this case, I don't need this guy. I don't need this guy. I don't need a transmission. I can directly send the traffic to the ISP. And that's the beauty of public IP. But again, you have to pay the money. Now, cost you, how much money you have to pay? It's depend. Like for me, as I told you that I'm also using the public IP, right? So I'm paying per month basis, right? Almost the bill is coming something around 300 rupees, which comes like a $5, $4 to $5. So depend on the country, depend on the location. This price will be changed as well. Okay, depend on the requirement as well. This price will be changed. So I'm just using for the only one server. That's all. So I'm just paying for this one. All good, right? So that's we have done. Now, one thing, right? Let me tell you something. So take example. We have some user, some folks, right? PC1, PC2, right? PC3, PC4, come on, right? And PC5. Guys, please be on time because I have to always make admit all the person, right? So it's distracting. Okay, so these are the PCs we have. So let me write on the name of the PC. PC1, PC2, right? PC3, PC4, and PC5. Take example, I'm gonna use the subnet is what? 192.168.1.0/24. So you can define the subnet mask like this way as well, right? If you're defining in this way, that's also a good way, right? Or you can also define this way. So if you're defining this way, that's called a CIDR value, classless interdomain routing, right? And if you define the complete way, you can define. So this is the concise way to define subnet mask information. Now you may have a question, log, can I define on the router side and can I define on the PC side? It's depend on the device, they are vendor by vendor. In Cisco, some of the router you can define the subnet mask like this way. Some of the router doesn't allow you, so you have to go with this way. So it's depend vendor by vendor. So whenever, one thing is very important, whenever you stuck in some, like in an interview, okay, what happened if I'm not defining in this way, will this command will be accepted by the router? So sometimes interviewer are putting a tricky question to you, right? And you on that time you may get confused. Okay, what should I tell you? So don't confuse on that time. Just say that it's depend on the vendor. It's depend on the product. Because you have because you are working for the Cisco right now, right? You're reading the Cisco documents, right? You're taking the training for the Cisco. So maybe you're getting the job in the Juniper, or maybe you're getting the job in the Palo Alto. You have no idea of the Palo Alto and Juniper, right? So on that time, just say that, okay, it's depend on the vendor by vendor. Okay, so what I can do that, I'll define the IP address for this guy's 192.168.1.1. Read subnet mask /24. This guy will be 1.2. This guy will be 103. And this guy will be 104. And this guy will be 105. That's all. Now, same way, I have another user as well. So take example, I have another PCs as well. Copy and paste this guy and this guy. So I'll define the name of this guy as a PC number 2 and 3. 2 and 3, right? This guy is gonna use the another network. Now same still, but you can see that it changes, right? It's a different network. So this PC also have IP address now 2.1, 2.2, 2.3/24. Okay, so normally what happened, in this case, this guy will create a own logical area, right? So what happened, this, whatever the IP, you can see that 1.1, 1.2, 1.3, 1.4, 1.5, what happened, they are part of the same domain right now. So what he will do that, he will create a one logical domain, right? He will define the one area, right? He will define the one logical domain. And what this domain is called as, this domain is called as a broadcast domain. Why I call it a broadcast domain? Because right now, all this PC, right? PC1, PC2, PC3, PC4 is a part of the same subnet. And if it is a part of the same subnet, right, we call as a same broadcast domain. All this PC are the part of the same major subnet, right? And if it is a part of the same major subnet, then we can call as this guy is part of the same broadcast domain. It means that if you have a one switch in between, take example. If you have a switch in between, okay, so I'll just connect the switch, right? This way and this way. Do you know what happened? Take example, if this PC1 is gonna send any packet, right? The source will be PC1 and destination address is a broadcast address. Take example. Do you know in that case what happened? Right? This packet comes to this guy, this guy, this guy, this guy, this guy, and this guy, because they all are part of the same broadcast domain. They are all part of the same subnet, or we can call it the same broadcast domain. Same thing, what he will do that over here as well. If you see, this 2.0, PC1 has a 2.1, PC2 has a 2.2, 2.3. What they will do that, they will get the another logical domain. And this, again, logical domain have a own broadcast domain. Right. Again, in this case, what happened? You have a switch in between PC1 and PC2, PC3. Switch 2, I can call it, right? And I do have a connectivity, right? So if the PC1, again, try to understand, if the PC1 will send any broadcast packet, so we have a PC1 is a source IP, and destination will be broadcast IP, right? It will send the packet to the every person. But try to understand one thing, within the broadcast domain, right? Within the broadcast domain, user can communicate with the help of switch. So by default, right, By default, the communication is allowed. Guys, please pay attention to my words. By default, communication is allowed within the own domain. By default, communication is allowed within the own broadcast domain. So if the PC1 will send a traffic to the PC2, they can send it. PC1 will send the traffic to the PC3, they can send it. PC1 can send the traffic to the PC4, they can send it. There's no issue. But what happened if the PC1 wants to communicate with another PC in the different broadcast domain? This communication will be not allowed. Not allowed. If you want to provide, right, by default, it's not going to work, right? If you want to provide the communication between the two different broadcast domain, then what you have to do, you need to bring a new device, new type of device. You need to bring a new person, a new guy in this picture. And that guy name is called as a router. So the use of router is what? Right now, okay, because right now we are learning the basic part. Right now, the use of router is what? It's going to provide the communication between two different subnet. So now, previously it was, so if I'm going to remove the router, no communication will happen. If I'm going to add the router, now I can send the traffic from the this source to the this source. For example, if I have a packet, which is the packet like this way, we have 192.168.1.1 and destination is 192.168.2.1. I can send the traffic easily like this way. Sorry, not this way. I can send the traffic. There is no issue. So router is a component, right? Router is a device that will provide the communication between the two different broadcast domains. If you don't have a router, you cannot provide the communication between the two different broadcast domains. So now you may have a question. So right, hey Law, is it possible without router can I provide the communication between the two different broadcast domains with the help of switch? Yes, you can. So normally your switch, your hub is a layer 1 device. Okay, that's my physical layer. Your switch is a switch, or we can call as a bridge, right? So I'm not gonna use the bridge term now. Okay, I'm just using the last time. Okay, bridge is a layer 2 device. That's called a detailing layer. At the same time, right, your router is a layer 3 device. That's called a network layer. Your switch can be layer 3 as well as. So if somebody will ask you a question, hey, can I provide the communication between two different broadcast domain? Can I provide the communication between this broadcast domain to this broadcast domain? Right? You can see that we have a different broadcast domain. You can identify from here, right? This bit is changed. Last third octet is changes, right? Third octet is changing. So two different, yes, you can provide with the help of layer 3 box, a layer 3 switch. Again, I'm repeating, guys, don't worry about each and every words like what is physical data and network, right? I'm just making you familiar, okay, these words right now. And we are going to discuss about the layer 3 switch, right? We are going to discuss about the routers. We are going to deep dive of the switching as well. But I'm just going to making you familiar with the words. So this
Sir,
is, yes.
L3 means sir core switch, sir.
What is the core switch? What do you mean the core switch?
No. You write just now, sir. L3
No.
means core switch. L3 switch means core switch.
What do you mean by core switch?
No, I am just asking, sir.
No, there's no core switch and something. Okay,
Okay.
no, so right now leave that. I understand your question. Okay, but I just wanted to know from your side. I understand you're
Okay,
doing
no.
core right now. Okay, so just leave it right now, the core, and I understand you are asking about the core, right? Distribution and access layer, something, right? So let's
Okay,
leave
no
this.
issue, sir.
right now. We'll discuss.
When you start, I can.
Yeah, definitely. Don't worry. Understand in a simple way, switch, either it can be the layer 2 switch or either it can be the layer 3 switch. In the layer 2 switch, you can provide the communication LAN to LAN, right? Right, which is this guy, switch 1. Layer 3 switch, you can provide the communication LAN to LAN, at the same time, LAN to WAN. And again, WAN to WAN too, right? So this 3 use case we have with the help of layer 3 switch. LAN to LAN, LAN to WAN, or WAN to WAN. All good? Now, take example. Okay. Help me out one question to you, all of you guys. 192.168.1.0, right? Or slash 24 we have, or I can simply write .255.255.255.0, right? You tell me one thing, how many host IP address will be there over there? As I mentioned that, if you remember the classes, I told you that in the one subnet, right? One subnet,
245.
how much?
245. No, I mean
254.
254. 254. Sir.
254, right? So I told you that if you guys remember, in a one subnet, you have a host IP addresses, right? You have a broadcast IP addresses, and you have a network ID too. So you can also say that broadcast ID, simple language we can call it a BID, and we can call it a network ID as an NID. So normally host IP in a one subnet, I mean say the one broadcast domain also you can mention like that. Okay. So in a one broadcast domain, you may have all these things, right? Host IP address will be there. That is, you are gonna use to assign to the PCs, right? You're gonna assign to the router. You're gonna assign to the switches. You're gonna assign to the server. You're gonna assign to the printer. You're gonna assign to the refrigerator, right? Anything you can assign the host IP address. Broadcast IP addresses, you are not gonna assign to anybody. Not assigned to anybody. This broadcast IP addresses represent a group of people. This broadcast IP address represent a group of people. Let me take an example. So understand this concept. So I'm going bit slow now, okay, because you need to understand this concept. I switch PC we have, okay. So we have a switch 1, okay, and we have a IP address for this guys. Let me use it. /24. So you can see that, right? I'm assigning the host IP addresses. These are the host IP addresses, right? These are the host IP addresses. PC1, PC4, PC2, and PC3. So in this range, right? In this range, what happened? 1.0 from 192.168.1.1 to 192.168.1.254. These are my host IP addresses. These are my host IP addresses. 192.168.1.0, right? These are my network ID. An ID we can call it, right? Simple language. And 192.168.1.255. That's my broadcast IP. BID. Every subnet has a 3 things, right? 1, host IP address. That's this guy from this range to this range that you are going to assign to the hostage, right? Even take example. Let me add one more thing over there. I have a right? I have a server. Okay, server 1, I have a server 2 now. So 2 server, we have, take example, this is my Gmail server. Okay. And this is my YouTube server. Okay. So if you guys remember, I told you the definition of the server. Server is nothing but just a computer, but it has a powerful storage. Okay. So in normal computer, but it's has a powerful storage, like a 1024 gig RAM, 10 TB SSD. And this guy has the IP address is what? So 192.168.1.5. And this guy is a 192.168.1.6/24. Guys, now pay attention. Can you see that I'm still using the IP address from this range? I can also allocate this guy as a 254 IP address. 192.168.1.254. It means that all this guy, can you see that? They are the part of the same broadcast domain. Now, what happened? Try to understand. If I'm going to add another PC over there, and I'm going to make this guy just switch one, and I'm going to provide the IP address for this guy's 2.1/24. You know what happened? He will create the own broadcast domain over there. Can you see that? What's happening? Previously, I had a one broadcast domain. I just added another PC with a different subnet IP address 2.1. Can you see that? He created another broadcast domain. So what happened if this guy, take example, if this guy is going to send any broadcast packet, on which address he will use it? So what I told you, that every subnet has a dedicated broadcast IP addresses. Every subnet has a dedicated broadcast IP addresses. That's called as a BID. The last IP, listen to me carefully. The last IP of the subnet. The last IP of the subnet is called as a broadcast IP. The first IP of the subnet is called as a network ID. Again, I'm repeating, you are not gonna assign these IP addresses. These IP addresses means what? An ID and BID to any host. etc. You're not going to assign it. So try to understand the diagram that I have right now in front of you, right? The diagram that I have right now in front of you. If the PC1 is going to generate any broadcast packet, what he will do that? Take example, right? This PC wants to inform to everybody, hey, you know one thing, tomorrow is a holiday. Like take example, this PC is a manager PC. This PC is a manager PC. And they all are my employee 1, employee 2, employee 3, and these are my server, right? This implies a different broadcast domain. Try to understand right now. Is a employee 4, this is a different broadcast domain. So if this manager want to send a traffic, hey, tomorrow is a holiday for sales team, right? You know, when this guy will send any broadcast packet to the switch one, what switch one will do? It will send the packet to this guy. This guy, you see that he's not sending to this person. He will send to this guy, and of course my servers as well. But I'm not gonna send any broadcast packet to this PC, because this PC is a part of the different domain right now, different logical domain. So broadcast IP, I'm not assigning. So how do I send the traffic? I will just say the ping 192.168. What is the last IP address for this guy? 1.255, right? I'm going to send the traffic to this particular network. So when I'm going to send the traffic to this particular network, it means that I'm sending traffic to everybody. If I'm saying the ping is what? Ping is a command, right? That works on the ICMP protocol, packet internet group, right? Internet control message protocol. Ping is a command. So I'm saying that, hey, listen, send the traffic to everybody. So whoever the part of, right, whoever the part of this particular broadcast domain will receive the traffic. This guy, the employee 4, is not a part of this domain, so he will not receive the traffic. But every guy, right, PC4, PC3, PC2, Gmail, and YouTube server will receive the traffic. Guys, any question do you have till now?
No, sir.
Right.
Sir,
No.
sir, ping command is used only for the check the network connectivity check, na, sir?
Yes, for now, yes. Ping is for the check for the network connectivity. That's all. Now, so these are the basic part of the network IPs of, so every subnet this we have this IP. Now try to understand how many is IP we have in this case. We have almost 254 IPs. We have a 254 IP. Okay. Huge IP addresses we have. Take example. I have a one company. Okay. I have a one company. In this company, I have a 3 floors. Floor, third floor. Okay. We have a second floor. We have a first floor. Let me take a big size. I don't have a space. I have a space. Okay. Down split. Third floor. Second floor. And first floor. Floor, right? Now we have some user. So take example. Let me take a small size. PC1. I'm so sorry. PC2. PC3. PC4. And now I can copy the complete part. I'll just make the name as well. So this is a PC1, PC2, PC3, PC3, and PC4. All done. Copy and paste. And copy and paste. Okay, right? So we have a 4 PC on the third floor, 4 PC on the second floor, and 4 PC on the first floor. This third floor is totally dedicated for the IT department. Okay. Second floor is totally dedicated for the sales department. This is for the management department. You tell me one thing. What I want, first I'll tell you. Let me write on the IP addresses too, then it will be easy to understand. So every person has IP addresses, right? Because on the internet, every user must have IP addresses, right? 101. I have a space, so I can write a space. /24. 102. Okay, I'll just remove the /24 because otherwise it will become a little complex. 103 and 102. And I'll write down /24 over there. So this is the guy we have. Now, question to you. What I want, first of all, I'll tell you. I want the IT department should not communicate with the sales department. What should I do? Can I use the same subnet IP like this way?
No, sir.
We can create a VLAN.
Forget the
VLAN
VLANs.
10,
Forget the
VLAN 20.
VLANs. Forget the VLANs right now, guys.
Okay, but we can create a different, we can use a different subnet like 2.1, 2.2,
Exactly,
2.3.
right? Because either what happened, we need to go with the VLANs is a different thing. Let's leave it right now. Okay, we are not going to discuss right now. What we have to, right now, the solution is what we have discussed till now. The only one solution is what? If I don't want to provide the communication between the IT department and the sales department, I just need to make a different broadcast domain. So I'll make this guy as a 2.1. This guy should be 2.2. This guy should be 2.3. And this guy should be 2.4. Okay. Subnet will be now let's go for this guy. Same thing for this guy. 192.168.3.1, 3.2. This guy should be 3.3. This guy should be 3.2. This guy, the subnet will be. So right now we have a 3 broadcast domain. Broadcast domain number 1, broadcast domain number 2, and broadcast domain number 3. 3 broadcast domain we have. So it means that, take example, if PC1 is gonna send any traffic, I said the source will be 192.168.1.1. That's my source. Okay. Destination, what I can put 192.168.1.2. This packet is called as a what? Unicast packet, right? Take example now. 192.168.1.1 is the source, and destination is 192.168.1.255. What happened in now? So if the PC1 is going to send this packet, right? Send this traffic, it's a broadcast packet, right? So in this first packet, what happened? The only communication is going to happen between the PC1 and PC2. But if I'm going to use the second packet, this one, in this case, what happened? I'm sending the traffic to this guy, and this guy too. To everyone, I'm sending the traffic. That's a broadcast IP because I'm pinging to the broadcast IP. Same thing for the sales and same thing for the management. Take example, if this is the manager PC, understand this concept, guys. This is the manager PC. Right? These are the manager PC. So if the manager wants to inform, hey, today is holiday, this message the manager wants to send, today is holiday for sales department, right? What he will do that? Simply the manager, this manager will create a packet where you have a source IP will be 1.2.1, right? And destination will be a broadcast IP address 2.255 and send to the everybody. This is how the normal communication will work, right? That's fine. There's no issue in this case. But do you know the problem? The problem is what? In this subnet that we have used for the IT department, 191.168.1.0/24. In this subnet, if you see, I have almost the host IP address. If I talk about, I have 192.168.1.12. The network ID, what is the network ID for this guy? What is the sub broadcast ID for this guy? Same thing if I look for this person. I'm sorry. Same for I will look for the 1.2.0, right? And 2.1. And this will be the 2.254, right? Same one for this guy as well. And this guy as well. Same for this guy as well. Management department. Increase the size. Okay. Host IP address will be 3.1. And this will be the 3.254. Right? This guy should be 3.0 network ID and 3.255 will be broadcast IP for the management. So we have a separate thing. Now understand. I took the 3 different subnet. First of all, I took the 3 different subnet. In the first subnet, right? In the first subnet, if you see that, I only utilize the 1.1, 1.2, 1.3, and 1.4. Only this IP addresses I have utilized. It means that all my 200 IP addresses wasted. So maybe you can say that, hey, law, one thing, my planning is to introduce the more PC in future. I'm not denying it. You can introduce it, 20 PC, you can go with the 30 PC, but still you are wasting the IP addresses. Take example, you have utilized in future, you're planning to add the 30 PCs, 30 plus 4 what? 34 now. But still, if you see, how many IP addresses I'm listing? 230 almost, right? Not 230. What? 224. Still, you are wasting the IP. Same thing is happening for this guy as well as. If you look for this guy, same thing is happening for this person as well as. Not 200, 250 IP addresses wasted. For this guy as well. For this guy as well. So if you have a look, right, every subnet, right, on every subnet, you have a wastage of IP addresses. Maybe you can say that, law, I'm planning to add the 30 PC or 50 PC in future. But can you imagine that even if you add the 50 user over here and plus 4, right now we have 54 over there, 54 over there, still you are wasting of the 200 IP addresses over here, 200 IP addresses, because still you have left with the 200 IP addresses, right? Because still left will be what? 192.168.1.55 to 254. These IP addresses are wasted on this subnet. Again, same thing. These IP addresses are wasted in this subnet. So can you imagine that what's happening over there? I'm not saying that it's a bad thing. I'm just trying to help you. IPs are not free. So maybe you have a question, hey, law, you took the example of the private IP. That's fine, man. You can assume that with the public IP too, right? I took an example of the private, but instead of private, you can make a 190, you can go with the 191. That's public IP now. Anyway, right, you are wasting the IP addresses. You have a requirement of the 4 PC, you have a requirement of the 20 PC, go for the 20 PC subnet. If you're going to utilize, if you're going to put the one subnet 1.0/24 and still you have a 4 PC only, these IP addresses are totally wasted. On almost, if you see that in a 3 subnet, right, almost you can see the 3 subnet, you are wasting almost 600 plus IP addresses. You are wasting. And that's not a good solution.
Sir.
Yeah.
Yeah. My question is, how can you have a 3 subnets /24 within a same company? Can you explain me that, please?
Okay, can you repeat your question?
Yeah. You see, you have a 3 floors, right?
But I have a 3 different subnet over there. Can you say 1.0 we have, 2.0 we have?
Yes, but how can you have 3 different subnets /24 when we know the /24 subnet?
You can have it, right?
you...
Because I need a different broadcast domain, right? I can have it. It's a big deal. In a companies, what happened for the every departments, you have a different broadcast domain.
Yes.
Okay. So normally in a companies, what happened? We have a VLAN. Okay. But right now I don't have. We haven't introduced the VLAN concept yet, right? So if you don't have a VLAN, how you can differentiate the broadcast domain based on the subnet?
Yeah.
And that's why I use the 3 different subnet over there.
Yeah. And
if you have a VLAN, that again, in that case, you don't need a 3 subnet over there. You just need a 1 subnet and you can define it a different VLAN. That we'll discuss later on next week. Don't worry about that. Wait for some time, user. You will understand more things, right? Wait a minute.
Yeah.
Because I cannot jump everywhere, right? Because most of the people are like, freshers in this one team with classes. Okay.
Okay.
All right.
Thank you.
Thank you. Now, this is how, like, you can see the 600 IP addresses are wasted. And these IPs are not free. These are the payable IPs. So again, you may have this kind of question. Hello, I'm not feeling like, I'm not feeling anything bad about this IPs and subnet right now. The reason is that, okay, I'm using the 4 IPs for my sales department. You can allocate 1.5 with this guy, 1.6 this guy, 1.7 this guy, 1.8 this guy. And you may also have this question, Law, I'm still, not going to generate any broadcast packet. So even if you're not going to generate any broadcast packet, right, then what happened? I can define the IP address 1.5, 1.6 to this guy. No, you cannot define it. The reason, you know what? If you're going to use the different subnet, if you're going to use the same subnet for the different department, you will dealing with the security. Security comes in the picture. Understand this basic formula. Okay. If you're going to put all these guys in the single room, right? Anyone can fight with any other person. You have no idea. But if I'm going to put the person in the different room, then you have a security. What? The wall is a security, right? There will be no fight. Same thing, same concept will be applied over there. This is the wall. That subnet is a broadcast domain is a wall that helps us to improve the security. Now, question is that how we can avoid the wastage of IP. So you can avoid the wastage of IP addresses with the help of subnetting. Subnetting allows you to remove the or reduce the wastage of IP addresses. What subnetting will tell you? Hey, don't worry, I will divide large broadcast domain into small broadcast domain. Simple funda is what? Take example. You have a big room, right? What I can do that now, this is the one subnet, understood this concept, this is the one subnet. I'm going to divide this one into the multiple small subnets, small rooms. A big hall is now going to divide into the small rooms. Previously, this room was this size, right? Right now, this is before subnetting. And this is after subnetting. So the big room is now converting into the small rooms. So we have multiple rooms. Room number 1, room number 2, room number 3, room number 4, room number 5, room number 6, room number 7, room number 8. Now you can assume these rooms are what? A subnet, a broadcast domain. So can you see that what I did over there? I divided a large broadcast domain. I divided a large broadcast domain into the small broadcast domain. With the help of what? With the help of this beautiful guy, subnetting. And that's why I'm saying that. It's reducing what? Wastage of IP address. It's reducing what? Wastage of IP addresses. That's a beauty of subnetting. So big room, small, 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 small. Subnetting, right, has a two flavor. Subnetting has a two flavor. The first flavor is called as a FLSM. Simply fixed length subnet mask. It means that simple normal language, a layman language, right? Each network ID has a same subnet mask. Each network ID will have a same subnet mask. Let's go in a more simple way. This is the one room. What I can do that, I will now do the subnetting for this room. And now I'm going to divide into the equal size. Equal size, same equal size. That's called the fixed length, same size. Now, another flavor of the subnetting. Another flavor of the subnetting is known as a what? VLSM. Variable length subnet mask. Okay, variable length subnet mask. Name says the variable. Variable length means what? Now the size of the room will be different. Now the size of the room will be like this way, depend on the requirement. So now I feel like, this room number 1, right, should be big. So I will create a big room now. So room number 1 will be big. Room number 2 will be small. Same way, the room number 3 will be very small. Room number 4 also will be very small. And room number 5 will be small. So this is called as a variable length. Means, can you see that the size is very right now? So subnetting has a two part. Either you can define as a fixed length subnet mask information. Either you can define as a variable length subnet mask information. So variable means simple logic, different subnet mask will be there, right? Fixed length will be same subnet mask will be there, same block size will be there, same size will be there of the room, same size of the subnet, right? Same size of subnet. That's called as a FLSM. Variable size of subnet. It means that, understood this, what I told you, that in a one subnet, you have a host IP addresses, you have a network ID, you have a broadcast ID. These three things I told you, right, in one subnet. Same size subnet means kya? In a one subnet, right, what happened, you have a, take example, first subnet will have a, first broadcast domain you can call as a, right, or subnet, you will have a 20s IP. Take example, not 20, 30s IP. Okay. In second subnet also, you only have a 30s IP. In third subnet also, you only have a 30s IPs. Every subnet has an equal range of IP addresses. That's called as a FLSM, fixed same size of subnet. When it comes to the variable size of subnet, it means that in a first subnet, it may be 30. In a second size of subnet or broadcast domain, we can call it subnet bolo ya broadcast domain bolo. You can say that, anything, it's fine, right? I have maybe 6 IP. In third subnet, a broadcast domain, I may have a 62's IP or maybe 60's IPs. Can you see that? That's a difference in the FLSM. Same room size. IPs are same block, different room size. That's called a VLSM. subnets are different. Each subnet has the three things, broadcast and this one. Questions? Does anyone have questions?
Yes, I have a question, sir.
Yeah.
What I'm saying, if you say the three subnets, six sorry, IPs, so
30,
I mean,
we have a 36 and 66. 60.
are these are the examples or what? I mean,
This is just an example. This is just an example. I just want to confirm that the variable, the meaning of variable is what? We have a different range of IP addresses. But in the fixed length means fixed size of IP addresses. Just example.
okay. So if I say one subnet, so it's 30 IPs, 30 broadcast domains, right?
No, 30 host IP.
30 host IP. I see. Okay. 30 host IP.
When I say when I'm going to use the IP terminology, understood, I am talking about the host.
Okay, so there's a network part and there's a host part.
Yeah,
Those
of
three.
course, in a each subnet, I mentioned that you have a host IP,
Mhm.
network ID, server. So this subnet also have a separate broadcast domain, separate network ID. This subnet also have a separate broadcast domain, separate network ID. This subnet also have a separate broadcast domain, separate network ID, and IPs.
In VLSM.
You're right, that's a VLSM. Same case in the FLSM, they have a separate network ID and broadcast ID and IPs. Separate network ID and broadcast ID, IPs. Separate network ID and broadcast IDs, IPs. FLSM. But it's
Sorry.
a same.
Yeah, I have a question.
Go ahead.
Yeah. For example, if you get from your ISP
Mhm.
C-class address,
Okay.
and the C-class address means 254 addresses,
Right?
can you use in your private network more than 254?
No. It's depend
No.
what size of subnet they are giving you. For example, if the ISP is giving you,
Mm-hmm.
hold on, let me take it. I don't have the space. Take example, if what we call, yeah, I'm so sorry. If ISP is giving you to the customer,
Mm-hmm.
you requested for the IPs, the public IPs, because private are free to use, you can use it, but you request for the public IPs. So take example, I request for the range, I requested, customer requested for the ISP, hey, I need a, complete C class of IP, complete C class. Then he will give you the 192, so not 192 dot, take example, 200.200.1.0/24. So
Yeah.
this is the range of the public complete subnet. So in this one, how many IPs are there? 254, right?
Yes.
One network ID and one subnet broadcast ID. What will the network ID?
Broadcast ID
200.0.1.0. That's a network ID. What is the broadcast ID?
1.254.
255. Sorry, 255, not 254.
250.
And these are mine?
Acha, sorry, 255, sir.
1 or 1, 2?
254.
254. Great answer. So this is the range that you have asked, not the ISP is giving you. You requested to the ISP, I need this range. So ISP is giving to you. But if you're gonna ask to the ISP, hey ISP, do you know what? I just have a small subnet I have, right? That they can give you the based on the small subnet. Maybe they can give you the 200.200.1.0/32. Right? So in this, you may get the /30. Don't worry, I'll just write on that. Right now, you have no idea. I'm just writing down for you guys, just for the understanding. But we'll learn this part now. So
in this
one,
specific, okay, I'll let you speak first, please. Go ahead.
I didn't listen. Can you repeat your question?
No. Please go ahead. I'll let you speak first. Apologies.
Okay. So in this case, what happens? /32/30. So in this case, you will get the host IP will be 4 only. So if we take example, 1.12, 1.3. So network ID will be, it's a 1.0, and broadcast ID will be not 1.3, 1.2, and broadcast ID will be 1.3. So that's this range you have requested. You say that I need a 2 public IP addresses. So ISP will give you this slash value. So it's totally depend on the slash value. Because remember what I told you that subnet mask, right? Subnet mask will tell you how many bits of host and how many bits of network you have. So based on the bits, you are defining, okay, this is the huge range of IP addresses in the class A, this is the less number of IP addresses in the class B, and there are very less number of IP addresses in the class C. So based on the subnet mask, right, the ISP will tell you, okay, this subnet has these range of IP addresses. Understood? Yeah, go ahead. Questions?
In IP, the first 3 octets are network part, right? For example, on this specific IP address
The
200
first
or 200.
IP I mentioned that if you see that, I have written over there. I don't know where I written, but I mentioned that the first IP will be the network ID and the last IP will be the broadcast IP. Somewhere I mentioned that. Yeah.
So 192.168 1.0.
That's my
Yeah,
first IP. The subnet is called network ID. And the last IP of the subnet is called as a broadcast IP. And remaining in between, you have a host IP.
I see. So 0 and so basically 0 and 255, they both are the host ID, starting from 0 all the way to the 255, right? In between there is a host,
In between
isn't
this,
it?
these are not a host. So you are not going to assign. I have also mentioned there somewhere, right? If you see, there I mentioned that. You're not going to assign these IP addresses, the network ID and broadcast ID. These are 2 IP. Network ID, you're not going to assign to the any host.
Yeah, it will be assigned by the company to you, right? As an engineer.
You may say that. It's a block size. So it's a rule.
Okay,
It comes in the rule. So not in the ISP, it's a block size.
I see. So 24, that is a
Subnet mask.
that is a subnet mask.
Yeah, we can call as this is the concise way to, in a short way, a brief way to write the subnet mask, call as a CID, classless interdomain routing.
Right.
So
Okay, so
different platform, different way to define the subnet mask. So if I talk about the normal, you have a normal iOS router. So in the normal iOS router, you're going to define this way. But if you go to the XR router, the service provider router, you can define it. Even though you go to the Nexus switches, data center, you can define it this way. You know, different has a different way to define the subnet mask.
right, and in this specific IP, the first 3, 190 to 168, and that one, that one network parts.
Yes, that's great. This
Yeah,
3 things are network part.
okay, the first 3 octets are network,
Yeah,
and the
this
rest
is
is
the
the host.
I have
And the
also
last 24, that is the
subnet mask,
subnet mask.
CID.
Right.
I have mentioned that
CID.
this part. If you see,
Right. Okay. Sorry, I missed few class, so that's why I was apologies.
I totally understand. Don't worry about that. Okay, so you can
Thank you
see
so
that I
much.
have mentioned that in the class A we have a network 8%
Yeah.
and 3% is a host person. Same B class we have an 16 network person and 16 host person. And class C has 24 as a network person and 8 as a host person. So everything is written in the note. I'll do one thing. I'll share this paint file to you guys. Okay, just like
Yeah.
if you want to
Yeah.
take a screenshot, you can take a screen. You can put in your room as well, just for your knowledge, nothing else. Because almost
Yeah.
this file is full.
I mean, it will be brilliant if you can get the PDF copy maybe for this ones.
I don't know. Can I okay, I think so. I may convert in this paint file in the PDF one.
Yeah. Okay.
Okay.
Thank you so much. Really appreciate that. Thank you.
So, okay. Okay, so here I was there, right? So I was talking about the wastage of IP address. So you can remove the wastage of IP address by doing the subnetting. You can do the subnetting in the 2 ways. Either you can do the FLSM or VLSM. Now you tell me, guys, can I start the subnetting of example RC right now, or do you want to start it tomorrow? Because it's lots of theory today. That's why I'm asking.
No, by all means, I don't mind. I don't know.
Everyone
I
has
don't
a
know about
different digesting level, right? So that's why I'm asking.
Yeah, about other team. So I'm totally happy to go ahead. I have no problem at all.
Okay,
No issue, sir, from my side, sir.
चलो तो करते हैं.
Okay, sir.
करें सर, गो हेड करें, सारी रात बैठे हैं आज.
This is
Thank you so much.
now we have a space. So requirement is what now? So we have a, you know, one same example, I'm taking the same building example, right? What we have seen just now, this one, yeah. So this example, same I'm taking right now, okay. But in this case, I have used the three different subnet, okay. Three different broadcast domain I haven't been added and listed of IP addresses, right? So same example, now I'm gonna use it. So now my requirement is what? So take example, one of the ISP, right? And one customer. So customer said that, hey, you know, one thing, I have a requirement of 20 host IP. 20 host IP only. Matlab, I just need a 20. I have only 20 computers or maybe 22 computers as a 25 as well, anything. But it means that there's a range is between 20 to 30. So this is the subnet 1.0/24. That's a default behavior. 255.0. Requirement, understand requirement we have 20 host IP addresses. So it could vary the 30 as well, as I mentioned that. Okay. Right now, what we are learning, and let's let you know, we are learning the FLSM, fixed length subnet mask, where each block has the same size of IP addresses. Each room has the same size of space. Requirement 20 host IP addresses, right? 192.168.1.0/24. That's good. Now, the first thing, let me write on the binary part, decimal. So 2 to the power 0 is equal to 0. Sorry, 1. 2 to the power 1 is equal to 2. 2 to the power 2 is equal to 4. 2 to the power what we call on 3 is equal to 8. 2 to the power 4 is
सर
equal
एक चीज क्वेश्चन है, मैं यहाँ पे थोड़ा सा मैं भूल
to,
जाऊंगा.
go ahead.
हाँ जी. Generally, when obviously 2 multiplied by
I think
0.
so. You need to, Nasir, you need to speak in English because most of the people don't know the Hindi, right? So yeah.
Oh, sorry about that.
Go
Okay,
ahead.
sorry. Okay, so generally, so in this subnetting rule,
Mhm.
so when 2 multiplied by 0 is equal to 1, this is the standard rule for subnetting, right?
Right. Yeah, it's a
Okay.
standard rule. So subnetting, you know, if you go in the books, different books, different trainers, different person has given the different tricks to do the subnetting. Telling you.
Right.
So you just
Okay.
need to find your own way. The switch posture, right, is very important. Anywhere. If you're doing the like gym, if you're going to the gym, right? So do only those things that you like it. So only find your own solution, right? I'll just give you the one and
Sure.
just take it, right? Because in the books you will see that it's a very tricky parts are there.
No problem. That's fine.
64 to 7 is equal to 120. So 7 is equal to 128 and 8 is equal to. Okay, 128 we have to take because 8 is will go to the 256, which is beyond the class C, right? If you're gonna make a 2 to the power 8, it will go to the 256, which is beyond the class C because the range of is what? Class C till 255 IP addresses. In a one subnet, you can only have a 255 IP addresses. That's a 8-bit, 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 and 8-bit. So network portion, and host portion. So you only find the 255 IP addresses in the class C. Now, what's the most important factor you need to write? Write on the details of these subnet. or we can call it a subnet. What will be the details you have to write? Convert all this guy into the binary. So what will be the binary of 192? First of all, understand the binary of 192. You have to right, the first 128 you need to add. 128, right? Then the first bit will be on now. You have values right over there. Let me write on this way.
Yeah, that's correct. Yes.
Let me write on this way. Then you will understand.
Sure.
This way. 1,
No
1,
problem.
1, 4, 5, 6, 3, 6, 7, 8. So the value of this guy, let you know, 128, 64, 32, 16, 8, 4, 2, 1. Okay. Now, if you're going to add all this value, you will get the 255. Now, we need to find the binary of 192.
Right.
1 means on, 0 means off. Okay. So if you now find the 192, right, what value you should make it on? You need to make this value should be on, right? 128.
Yeah, this one.
This should be the on.
Yeah.
Okay. Then
And
can I
the
add the
next.
64 over there?
Yeah, sure. Yeah.
Yeah, we can add it because if I'm going to add the, pay attention guys, if you're going to add the 128 plus 64, it comes to the 8, 4, 12, 2, 6, 8, 9, 1, 190, 192, right? So it means that we just need to add this two value, and that's all because we have done. So now we need to convert all these bits into what? 0. So we can say that 1, 1, 0, 0, 0, 6, 7, 8. Guys, if you have any question, feel free to ask me, right? You feel free to interrupt me in between. Now, same thing. We need to find the binary of what? 168. So let's remove this guy again. Hold on. Now, again, now go for the block, this block. 168. What is the value of 168? We need to add this value, 168, sorry, 128.
Yeah.
Okay. Then
Can
can I add the
0?
64? I cannot add
No,
the 64,
no.
right?
No, we can't.
I cannot add the 62. So let's make it, this guy should be 1.
Yeah.
We have to make this guy a 0, right?
Yeah.
Can I add this 32?
Yeah.
We can add it, right?
Yes.
Because if you're going to add the 128 plus 32, it comes to the 160.
160.
Yes.
So we can add it.
Yes, we can.
Then 0, sir. Then 1. Then 0, 0, 0.
Hold on, bhai.
That's all, sir.
Hold on.
Yeah.
Okay, so now, again, what
Yes,
happened now? The value is now we have it's a 128 plus 32. It comes to the 160. 168 we have a requirement. Now we just need to add the 8 values, right? So we can simply make this guy as a 0, and simply we can make this guy as a 1 and 0, 0, 0.
Correct. Brilliant.
So now we have a 1, 0, 1, 0, 1, 0, 0, 0. That's good. Same way, we need to add for the what? 1 now. So let's remove this guy first of all. Go slowly. You will understand everything. Remove this guy. Remove this guy. Now, we need to convert this decimal into the binary. 1. We need to convert this decimal into the binary. So simply, right? We don't need a requirement of 128. We don't need a requirement of 64, 34, 68, 4. We don't have. We just requirement of this value. So all bit will be what?
0.
0, 0, 0, 0, 0, 0, 0, 1.
That's correct.
4, 5, 6, 7, 8. And of course, the last octet we have all set to 0. That's a host portion. So let's make it 0.
Correct.
3 and 3, 6, and then 8 and all that. Now this is the for the network. Now we need to write the same thing for the subnet mask. What is the binary for this guy? 255, 255. all ones, right? 128. We need to find the binary of the 255. You need to add this value, we 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 need to add this value, this value, this value, and this value. Then you will get the 255. Simple, right? 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Or somewhere I'm going to say 4, 6, 7, 8. And then 0, 0. Yeah. Okay. This is the write down the details of the network ID and submit. So just the details of this guy and submit mask information. That's all. Now, what is the requirement of host IP address? We have a requirement of the 20 host IP address, right? As I mentioned that in each subnet, right, has 3%. One is called as a host ID. It should be in the range. Second is called as a network ID. The first IP address of subnet. Third is called as a broadcast ID. The last IP address of subnet. Now, so what is the requirement of now? We have 20 hosts, right? Just find the.
Yeah.
Can I go to the 20 host in this value? One value? No. I cannot go in the 2 value as well as. I cannot go in the 4 because these are the just a 4 host IP will be there, right? In the I need a 20 host. I cannot go with this 8 as well. I cannot go with the 16 as well. I have to go with the 22. So the bit requirement we have is 2 or 5, right?
Right. So it has to be above that number, right? Above the requirement. Right?
Above requirement, not the below requirement.
I see. This is like a standard rule.
And this is not a standard. I love to do this way.
Okay, no, that's okay. I was just asking.
Yeah, that's a standard way. That's a global way, right? Yeah. But statements like write down the details of the network ID and something. These are my rules, right? So everyone has.
No, of course, yeah. This is the way you make us understand, but that's understandable.
So host requirement, right? We have a 20 host. So 20 host comes in 5 bits. So now we need to leave 5 bits in a host portion. It means host portion means what? 4th block. Guys, pay attention now. These are the very important. This portion is known as a network portion. Let me write down over here. This is the network. This is the network. These are the host. So we need to leave the 5 bits, right? Because 20 host comes in the 5 bits, right? 20 host comes in the 5 bits. Because if I'm going to make a 2 to the power 5 minus 2, right? Is equal to 32 minus 2 is equal to 30 host, 2 for the network ID and broadcast ID. The formula is actually this one. 2 divided n minus 2. That's a formula. N is a number of 5. So you can take the 4, 3 based on the requirement. -2 is going to represent that this person. So one IP for the network ID, one IP for the broadcast ID for each subnet, right? So 30 host we have requirement. So we have to go with the 5 bits. 5 bits, we need to leave the 5 bits in the fourth block. Fourth block means this block we are talking about right now.
Subnet mask.
Right. Because in this bit, we need to borrow it, right? We are going to borrow from host bit. So we need to leave the host bit. How many host bit we need to leave? 5 host bit we need to leave it now. So now if you're going to make a new subnet mask, convert. Step number 3 now. Convert. So already you have a default subnet mask is what? This is the default subnet mask that you have. 3, 6, 7, 8. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. And then convert the host bit into a network bit. So how many hosts we have requirement? 5 bits. 8 minus 5 is equal to 3. So we need to leave the 3 bits for the network. Now we have just converted. And the remaining will be same, right? 0, 0, 0, 0, 0, 0. That's a 5.
Yeah, sorry, we need a
We need a 5
three-
host bit, right? Because 20 host, right? 20 host comes in the 2 or 5, right?
yes, yes.
So we need to leave the 5 host bit in the host portion, fourth block. So if I'm going to leave the 5, the remaining 3 will be converted into the network, right? 1 is going to represent as a network bit. 0 is going to represent the host bit. So all these ones are now is a part of the network portion.
I see. But it's again it really if the requirement is
Go ahead, go ahead.
right
Go
now
ahead. No issue, go ahead. Tell me, what's it?
now the requirement is we need to leave 5 bits. If I say the requirements 6 bits, for example, I'm just saying.
Then we
for
need to
example.
leave the only this guy and remaining this guy will be 0.
Okay, so whatever the leftover is, that will be considered as a host part.
Right. So the one value,
yes,
right? The value 1 is going to depend on the network bit. I think so. You missed class. 0 is a host bit. So this 0, you can see that.
yeah.
This one's.
Yeah, great. That's fine. So it's a simple standard formula. Whatever the leftover is, yeah, that is a host part. Remaining will be the network part bit. That's it. Simple.
So this is the formula. This
sure.
is the formula to find the host bit. And now you can see that we have a total network bit. So now you have subnet mask is what? 255.255.255 dot what? What is the value of this guy? 3 value. Tell me. 128. The value of this guy is what? 128, right?
Yeah, 120, yes, 64 plus 32.
224.
224. Got it.
This is the new subnet mask.
That's fine.
What is the CIDR value for this guy? /27.
27.
/27. So we can write it this way: 192.168.1.0/27. Now, if you're not find the step now 4.
So 27 means 24 plus 3, right?
Right. Step 4 will
see.
be what? Simple. Find the network portion. How many network you have created just now? Previously, we had only one network. It means that previously we had only one broadcast domain. How many now you have created? Two to the power n. It means that 2 to the power 3 is equal to 8. So this one big subnet is now divided into the 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8.
I see. And that is the VLSM.
No, that's a FLSM.
FLSM. I see.
Fix it, because we are discussing the FLSM right.
Sure. Sorry. Yeah, okay.
So now we have a subnet number 1. We can see the broadcast number 1, subnet number 2, broadcast number 2, subnet number 3, broadcast number 3, subnet number 4, broadcast number 4, subnet 5, subnet 6, subnet 7, subnet 8. Bingo.
Thank you so much. That's understandable. Good.
So this is now divided into the small portion. I can reduce the wastage of IP addresses now. Now, remember the same example, right? I gave you. We have a 3 floor. Floor 1, floor 2, floor 3. Now what you can do that instead of using the 1.0 and 2.0 and 3.0 like that way.
Sure.
Right? Like that way. Now what I can do that. I'm only gonna use the 192.168.1.0 subnet /24. And now I'm going to divide this one into the small portion, whatever the requirement you have. Based on the requirement, I can meet the subnetting. So I don't need a 3 separate broadcast domain. I don't need a 3 separate broadcast domain. I just need a 1 separate broadcast domain. And this separate broadcast domain, I can divide into the small section. I can save the huge money. I can save the IP addresses. I can make a good management of the network.
Right.
And if I talk about the very high level things, you know, it helps you, right? Whenever you create some policy, if you go in the very high level. So like, you know, if you, the first part of the network design, you know, comes with the IP addresses.
That's true.
The proper IP addressing, right? It's a first and basic lesson of your designing the network. So if some person, right, is planning to go for the designing, these are the basic requirement that you need to pay attention. Very basic.
Right. Yeah, that's very important to understand.
Because if your IP address is not correct, right? If you're not put the IP address correctly, right, you cannot design the network correctly.
That's true. That's true.
The cost will be very high then. You will see the term capex, right? When you're gonna read some high level books, capex will be high, right? People are like, you know, network engineers, right? Network companies are investing lots of money on the management side. Management side in the sense of what? The logins, SNMP on those part. NOC team, they are investing lots of money over there.
Right.
They are investing the money on the designing part.
Yeah,
The
that's a basic part.
Then tag comes in the picture.
Yeah, that's a fundamental part of the design of the network.
Basic things are very important. You need to understand like how the subnetting works. And then you can go in the further, man. I'm telling you, like, if you have a great knowledge of the CCI enterprise or CCNP enterprise, you can jump into any field. Like you can go in the service part, you can go in the data center, you can go in the wireless, you can go in the DevNet, you can go in the security. But this is the foundation of the enterprise.
Now, it has to be strong.
Find the so now the most part comes in the step number 5.
Sure.
Find the increment number. I call this as a magic number.
Right.
So what is the increment number? So the value of this digit, right, from the right side, the value of this value, right, the value of this digit will be the increment number. So what is the increment number we have? What is the value of this guy? 128 plus 64 plus 32. So this will be the increment number. So take example, right? If you have a 1100000478, so this will be the increment number. If you have, so this will be the 35. So this will be the increment number. The value of from the right side, the first value from the right side, the first value will be the increment number, the magic number, and based on this, the block will be created. So now the 32, right? Starting with the 32. So the first octet that you have 192 dot. Now let's create the block. Step 6. Create block size. So now your first block size is what? 192.168. This is the 1.0/24, right? Previous one, the large broadcast domain. Now we have divided this guy into the small portion. The first subnet that we have a 1.0/27, right? It's called the first network ID. This guy is called the first host IP address. Then 1.32 will be the next block, right? Guys, 32 is the magic number. So 192.168 1.0.
31.
Next subnet is a 192.168 1.32 is the next subnet. Next subnet is 192.168 1.64 is the next subnet, right? So the last IP address of this guy will be what? Host IP address.
So you
30,
just keep
30 will be the last IP address. And
how
31 will be broadcast. So basically in this subnet 192.168.1.0/27, what we have? We must have three things, right? Host, network, and broadcast. So we have a host, right? From here to here. From here to here, we have a host, right? From 1.2 to 132. We have a host.
Yeah.
The first
Yeah, that's
IP address is always as a network ID. The last IP always as a broadcast IP address. Understood?
I see. Understood.
Now, the next block that you have over there is what? Is a 192.168.32, right? 1.32/27. That's my second network ID. 1.33. That's my first IP address of second subnet. First IP address of second subnet. What will be the last IP? 1.64 is my next subnet. Can you see that? 64 is the next subnet. So 63 will be broadcast. 62 will be last
usable
IP
IP
address
sir.
of this subnet. And 192.168 will be
last
1.63.
one.
That's my broadcast IP.
Okay. So last host IP address is the 62.
Right.
Yeah.
So this is the one of the major block we have, right? And this is the another major block we have. So this big broadcast domain is now divided further now. So 2 has done.
Yeah.
Let's do the remaining.
I see. That's very simple and easy way you described. Thank you so much.
192.168 or 1 dot. What is the next subnet we have? 64, right?
Oh,
Yeah.
So third network ID 191.168.1.65 will be
Host ID.
first IP
That's a
address.
first type address here. 120, 127.
Okay.
126.
96 or 187. 95, 96 will be the next one, right? 95 will be the broadcast. 94.
94.
Sir,
Hmm.
hello.
Listen, tell me.
Sir, means sir, 65 to 94 we can use, sir.
I think ऐसे होगा ना 0 to 32. Then 32 is the magic number. Add the 32.
Okay.
64. Add the 32. 96. Add the 32. Go on.
I see. So you are adding up 32. I see.
But that's my magic number, right? I have to find it.
Yeah,
Okay,
yeah.
sir.
Yeah. Okay. Yes,
So
that's
always
true.
the
Yeah.
increment will be happen. 32.
Through the
Always
magic.
increment.
Always. Okay.
Right. So that's one. So let's verify it, right? I have a Cisco packet tracer open. So I take it 2 PCs, right? And let's connect the cable. Same device, which cable? Crossover cable.
Yeah.
So IP
But
configuration. Yeah,
nowadays in industry there are smart cables, isn't it? They can automatically.
oh, that's I did the automatically right now.
Yeah.
I did the automatically. So let's define the IP address, the first IP address, right? 1.1, 192.168.1.1. Subnet mask will be what? /27, 224. /27, 224, right? That's IP address by subnet mask for this guy.
Yeah, that's true. Yeah.
So this guy has, I've defined the IP addresses 192.168.1.1/27. This guy I'm going to define 192.168.1.2/27. Right? Now, can I ping this guy? Of course, we can ping, right? Because same subnet, right? Same subnet, we can send the traffic. Same subnet, we can send the traffic, right? Because they are the part of same subnet. Can you see that? Same subnet.
Yes, sir.
Now tell me, if I'm going to define the IP address for this guy is a 30, can I ping this guy? Now this is 30.
That's a different subnet.
Pakka?
Oh, 30 can ping.
Yes.
We can ping.
Yes, we can. Yes, we can. Sorry. Yeah, we can.
We
Yeah.
can ping. So we are getting the reply, right?
Okay, you find the broadcast IP address. Where need to assign the broadcast IP address?
I mentioned that broadcast IP address you're not going to assign anywhere.
So,
Okay.
Go ahead.
okay, what the benefit for the broadcast IP address?
Then I think so. You have to wait. You have to rewatch the video today. Okay, today videos. Because let me complete this one. Then otherwise we'll come back to the broadcast. You watch this video today videos, and if you're not able to understand, I'll help you tomorrow again. Okay.
Okay.
Now, what happened if I'm gonna give this guy the IP address is what? 33 now. Will it ping?
No, cannot ping.
It cannot ping,
sir.
right? It's a different source subnet now.
Separate.
It's not working. That's your class C subnetting. Don't worry, I'm not done. Okay. I think it's always late. So what we can do that tomorrow, I'll continue with the same thing. Tomorrow I'll write down all the blocks in front of you, right?
I have a quick question.
Yeah,
sir.
Boozer, go ahead.
Yeah. For example, you see, we have here 3 subnets. Does it make any difference if we change the number of third octet? For example, subnet first 192.68.1 and the second subnet 192.68.2. Does that make any difference or not?
it's gonna create a difference, man, because you are changing in the third octet now. So you are creating a different broadcast domain. So what you are saying, you know, you are saying that 192.168.1.64, right?
Mm-hmm.
And also you say that 192.168.2.64 something, right? You say that X.
Mhm.
So can you see that? It's very in class C, you're right. In class C, third octet will change the subnet. Or we can say the third octet will change the broadcast domain if you're going to modify anything. So if you are going to use the same one, 1.1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1. So on, same subnet.
No, I mean in the different subnets.
What
Let's
do
say,
you
for example, if we have in the first subnet
Mhm.
192.68.1.0. For
Zero.
example, in the second subnet 192.168.2.32. Is that okay or not?
It's not okay. It's behave like a two different broadcast domain again.
Okay.
It's behave
I
like
got
two
it.
different broadcast domain.
All
See,
right, thank
simply,
you.
Boozer, I'll tell you one thing. If you're seeing the different values in the third octet, simply understand it's a different broadcast domain.
Okay. Yeah, I got it now.
Great. So
Thank
that's
you.
all, guys. So we did the verification of the subnetting 2, right? So always do the verification of subnetting, right? On the Cisco packet itself. Open a new 2 laptops. It will max take the 2 to 3 minutes, right? To verify your subnetting. And that will be good for it, boost your confidence level. Okay,
Oh.
and I hope everyone enjoy the class. Let me know if you have any questions, guys, for the today class. We'll continue from this tomorrow. Okay, again, I'm not done.
No problem. Just please, if you can share that PDF document whenever you can on WhatsApp.
Yeah,
That
definitely.
would.
I'll do one thing. Tomorrow I'll upload, not today. Tomorrow I'll
No
add
problem.
this video
That's fine.
and upload the file in the.
So is there any homework need to be done for this class today, or just like just?
I don't do that right now. I'll give you the homework. Don't do that. I'll
That's
give you.
fine. Just basically, I do watch this video again.
Yeah, just
That's
yeah.
it.
Please watch the video one time at least. At least watch the one time. Okay, if you're not able to
No
do the
problem.
2 times, but if it is
Sure.
possible to watch the 2 times, then watch it 2 times.
No worries. That's absolutely fine. Thank you so much.
Thank you.
Take care.
Anyone has any questions?
No, sir.
Last you give me some
Have a
trick.
good day.
When you connect the laptop, what is it? I do not understand.
Cisco packet tracer. I connected. So you were not there in the first 2 classes.
No, you said no. You said some laptop. If you connect, you can find out the subnet mask easily, quickly, like this. It says. Last, you give me some tricks. Last minute. Laptop.
I say. I'm so sorry. I said that. 192.168.1.0/24 and 192.168.2.0/24, right? So if you see that this value, the third octet value is different, it means that simply these are part of the different broadcast domain. Okay.
Okay, sir.
So recordings will be emailed, or I mean, how will get the
Same
recording?
drive, same drive now. Same drive. Link.
So I don't have it.
I'll send you that. No way.
Okay, great. Thank you so much. Take
Thanks.
care, sir.
Thank you.
Cheers. Bye.
Hey, thanks everybody. Thank you so much. I'll catch you tomorrow.
Thanks
Bye
so
bye.
much. Bye.
Have a great
Bye.
night.
Thank you.
Thanks.